Most people begin their AI journey at the surface. They focus on the interface, prompting chatbots, testing image generators, and stringing together automated workflows without looking at the code. This approach feels productive for the first few days, but eventually you hit a wall. You realize you are pressing buttons without comprehending the actual systems operating behind the screen. The real trouble starts when the software breaks. You run into a hallucination, which is when an AI confidently presents entirely false information as fact. Or you get an inference error, meaning the model failed to apply its training to process your new data. Trying to fix these issues without foundational knowledge is like driving a car without knowing what a steering wheel or brake pedal does. This leaves you with zero control over the machine. Mastery requires looking past the polished software interface and deliberately digging into the raw mechanics underneath. Despite the human-sounding outputs, artificial intelligence does not actually think, feel, or perceive the physical world like we do. Humans derive meaning from their environment. Machines only extract mathematical patterns. This process is visible in a standard visual classification task. When you feed a system thousands of images of dogs and cats, it isn't learning what a pet is. Instead, it maps out specific geometric variations. It measures the precise pixel distance between the ears and the angular structure of the snout. When you introduce a completely new image, the system measures those same dimensions and calculates the statistical probability of which category the data belongs to. There is no magic inside the box. Artificial intelligence is a strict formula: raw data processed through pattern recognition to output a calculated prediction. We categorize this technology in layers. Artificial intelligence is the broad umbrella term for any machine exhibiting smart behavior. Inside that is machine learning. This is the subsector where systems independently learn from raw data rather than executing manually programmed rules. The innermost layer is deep learning. This sector uses neural networks, computing architectures modeled loosely on the human brain's interconnected neurons to handle complex tasks like facial recognition. These systems require massive datasets, text, audio, or images, to establish a baseline of knowledge. Without this raw material, the layers cannot function. The model absorbs this material during the training phase. It repeats this practice until it is ready for prediction, its ability to accurately evaluate new inputs. An AI is limited by the quality of these inputs. If a system is trained on an incomplete set of demographics, it develops bias, meaning it will output systematically unfair results for certain groups. Without clean, diverse data and rigorous training protocols, the entire architectural hierarchy becomes structurally unsound. When you first enter the space, it is easy to get caught in the dopamine rush of new automation platforms and viral models. Mastery begins when you stop looking for the latest automation and start interrogating the internal mechanics of the software itself. Because these systems rely on precise mathematical patterns, the pursuit of quick, effortless results usually leads back to the surface-level confusion we saw earlier. Building value requires focusing on how to solve complex, real-world problems. Prioritizing this kind of foundational logic allows you to move beyond simple consumption and begin architecting truly robust, highly scalable systems. Studying the anatomy of artificial intelligence before you practice provides the most direct path to technical expertise.